Hello and welcome to this interview for the SDG Collection at Frontiers for Young Minds. My name is Athena and today we'll interview one of the authors of the research paper for SDG 2, Zero Hunger. Would you like to introduce yourself?
Hello, I am Maged Saad. I am a researcher at KAUST and also I am a CEO of a startup called GrowBiome.
Okay, so if your article was any news headline, what would it be?
I would say a tiny little hero from the dirt.
That's really cool. Can you tell us a little more about your research at KAUST?
Okay, I'm at KAUST from almost 10 years and my research is involved in plant microbial interaction and how can we harness the power of microbes growing in the desert for food security and for zero hunger aim.
So we wanted to ask a few questions on personal ambition. Why did you decide to research plants? You mentioned a startup earlier. Why might you want to create a startup on this topic?
Okay, for plant, I think it's very clear for everyone. Plant is very important. Plant, it is what we eat, what we wear, what we see, and as well as it's our life. So the plant, it is very important. And then plant in the desert was something very important and exciting as well, because how the plant can survive this extreme condition. This is why I choose to work with plant.
Oh, okay. That's interesting. Thank you. So what's the significance of plants in arid places compared to any other place?
Okay. So it's here a matter of adaptation. So every plant species have optimal condition, can grow with. And then here in the desert with a low amount water, high salinity, extreme temperature, makes the plant need to have a special characteristic to grow and to survive under this extreme condition.
And the microbes help them with those special characteristics.
This is what I'm coming to, because plant have physiological as an anatomy as a plant, it is needed. However, there is a tiny little hero already grow in the desert, are working in interaction with the plant, are helping the plant in several levels. One of them making the plant more nutrient available for the plant, increasing the immune system of the plant, as well buffering the system from the pH, for example.
Buffering. I like that. Thank you. So in your paper, you mentioned some extreme weather conditions.
Yes.
What specific extreme weather conditions would you be referring to? Okay,
so we mentioned the word extreme several times. So one of them, it is a high temperature. And actually also not only the high temperature, but fluctuation of the temperature from a very hot days and very cold night in the desert, which what the plant experience here. Second, it is the UV index. So we have a very high UV index, and UV, it is sometimes it is not very good for the plant, as well as drought, very low water content, plus the salinity, because the salinity, it is very high in different area here in the desert. And the last but not least, the pH. So the pH, it is really very high, it is very alkaline in most of the area here in the desert of Saudi Arabia.
So you mentioned a startup earlier.
Yes.
What was your personal driving ambition to creating a startup in the first place?
It was only one thing. How can we translate our fundamental research to a solution, translated, applicable, and used by the people? And working with microbes and working with food security was the first and the good path to translate via the startup.
So the startup provides a product, a service?
In fact, the startup actually built on the fundamental research was being done in the lab, where the discovery was happening and the mechanism was being discovered about how this microbe are helping the plant. The startup doing what we call it a turnkey solution, starting of assisting the issue, which is, for example, the soil, finding the solution from the microbes, and providing the product back to the farmer to use it for helping with whatever problem was. If the problem is fertilizer and nutrient content, we provide microbes that can help the plant to use the nutrient. If it's a problem with the pH, we have also a product that can do that. So we are trying to tune the microbial or tailor the microbial soil microbe to help the plant once more.
So it's directly to the farmers too?
We targeting farmers, which is the first for the food security and also for the regreening as well.
My first question for you is, how does sustainable agriculture help achieve food security, and why is this important to Saudi Arabia?
Oh, it's a very big question because, we need to feed people and we have a very limited area for growing plant. Plus, all these issues related to the global warming, high temperature, less water, salinity. So the challenge is how can you feed the people with the same area we have now? So there are different possibilities to that. One of them that you can increase the productivity per acre square, as well starting coming with new plant can resist the extreme condition. And here our research and our paper come, how can we harness the power of microbes which helping the plant to grow under the extreme condition like the desert, and we can translate this one as a food security, and if you have the same area we can produce more food in one place. Second, we can use a new area to be added, which is the desert, growing more plant to feed the people, and this will go very well for decreasing the hunger and will go for the sustainability point, which is zero hunger.
All right, that makes a lot of sense. Okay. In the paper, you mentioned how you found over 10,000 microbes that might help plants grow better. And so how do you determine which microbes are more efficient in aiding the plants in the extreme weather conditions in Saudi Arabia?
Wow, this is really a big question. In order to collect this 10,000 or plus, took us almost 5-7 years.
Wow.
So how did we collect it? It's a very long story, visiting different places. How we identify these people? So we had a very systematic scientific approach, starting from knowing who is there, and then by using genome sequencing, so we know what is the name of the bacteria based on whole genome sequencing, bacteria or fungi. Second, we're starting making different pipeline, targeting what problem we are looking for. For example, we have an issue with nitrogen, and we would like to use finding microbes can help the plant to grow under nitrogen deficiency. So we're starting making pipeline of screening all these microbes under low nitrogen content and see which guy of this will help the plant to grow under the low nitrogen content. And this is the microbe which we'll use. So over the last 10 years, we established several screening pipeline, one for the heat to try to find what is the best microbe to help the plant to grow under the heat, for the salinity, for the drought, for the nitrogen use efficiency, as well as for nutrient acquisition. So the result came by multi-omics technology, by screening, genome sequencing, and in the end we're starting implementing the AI for mixing all these data together to come with a solution and know which microbe or which group of microbe can help the plant to grow under one condition.
So in the paper, you talked about special substances produced by rhizobacteria that help the plants grow better and help them not get sick. Could you elaborate on what these special substances are?
Okay, so microbes, they already have different capability of secreting hormone-like compounds, which is really mimicking the plant hormones, which is something like abscisic acid, indole acetic acids, strigolactones. All these different names of chemical compound, they having a special function in the plant during their development. For example, some of them, they are helping the plant to have a long root system or developing the root system. Some of them, they already have more branching of the leaf, and so on and so on. And this bacteria, which has been discovered, we found they already have the capability to produce such hormone or such compound, which can mimic the effect on plant and helping the plant to grow better under this extreme condition. For example, some of these bacteria, they are producing some AAA, indole acetic compound, which is really helping in the root system and helping the plant to grow under the drought condition, and so on and so on. The inventory of metabolic products and compounds secreted by bacteria is really huge.
Okay, that was a great answer. Thank you. And how will your work contribute to the global efforts to achieve SDG 2, Zero Hunger, particularly in other regions with more conventional agricultural practices and climates?
Okay, so the work in microbes are really fit with different condition. In arid land, it was very good because it really can help the plant or the people to grow more food with less input from the fertilizer, which is what you need. And also more sustained because you are also decreasing the dependence on the chemical pesticide, which is something really very bad. So you are looking for something more sustained and also for the healthy of the soil as well for long term. And as we are decreasing the chemical input, so you are getting the soil getting more healthy, which is really reflected to be a healthy plant. For area with really have an agriculture, exist agriculture, you are increasing the food productivity in this area with the decrease of the input, as I said. And for a farmer perspective, this means that more money he will gain.
Yeah, okay. Thank you so much.
Okay.
What structure does a desert plant have that makes it special or better than normal plants?
Okay, desert plant have different characteristic and also feature or anatomical and physiological feature make it different than the normal plant to survive on this extreme condition. One of them, we have less water in the desert. So most of these plants have a very long taproot system. So they really grow their plant very deep, what we call it a taproot, so they can really reach the water. One thing as well for the hot, the heat, so the plant already have a different system like a wax over the leaf, which is decreasing or minimizing the evaporations of the water from the plant. One more thing as well can happen, it is the number of stomata. You know the stomata?
Yeah.
So there are less number of stomata, so they are decreasing the amount of water. What else more? So there's more and more. Also the structures of the leaf system. You'll find most of the leaf are really reduced to be kind of a needle to decrease the surface area which is exposed to the heat. So they are decreasing the amount of the evaporation. So the plant already been tuned to be survival in the desert. Maximize the amount of water, decreasing the release of the water, as well as have the tools to get more water from the ground.
Assalamu alaikum, how are you?
Alaikum assalam wa rahmatullahi wa barakatuh.
So I'll be asking a few questions today.
Please go ahead.
How can schools and young people help to fight the world hunger?
I think it's only one, if someone would be fighting, it's only the school.
Yes.
Because young people, when you start making the awareness in the young age about how important for to do every practice to secure and to keep the food security going on. For example, if as we mentioned in our paper, if you already know how to recycle, how to use less fertilizer from chemical fertilization. So the students, when they're starting know or implant it from the beginning, that we can be more organic, try to use more decreasing the chemical fertilization will help in future, that they already been aware with the dangerous with what we are facing, so they can really provide solution.
Okay, so thank you. The second question is, what is the most important thing you would like us to learn from your article?
There are many things actually in the article that keep your eye open. Try to don't underscore the value of any organism. And one of the best example, which I already mentioned in the article, desert, which desert is not a naked area, but there is a lot of life. Yes. And the life in the top of above the ground and under the ground. And the microbes, and the tiny microbes can really be a solution or providing a solution for a lot of our problem. And then I believe the solution will come from the desert. Not only will help the desert area, but will help all the world, especially with the global warming changing and the weather changing in different places which used to be cold, they become a heat wave like in Europe and so on. So desert already have solution for a lot of problem we are facing now, especially in the food security.
So like the desert also has lots of organisms in it, just like underwater, and like it shouldn't be seen as just a regular habitat, right?
In fact, the ecological system or desert habitat, it is really very special. They have, the Swiss Army knife?
Yes.
So they have different tools.
Yeah.
So the desert have the same. So they already have all the equipment helped by the microbes. They need to have a very long root system. They can go deep. So they have microbes. They help to do that. So they already have nitrogen. Nitrogen is very, very important for the plant. However, nitrogen in the desert, it is really very low. Organic matter is very, very low. And then what's happened? Small, tiny microbes, it's called rhizobia. They are able to fix the atmospheric nitrogen and provide it to the plant. So it's again a helper, free of charge. They just take the nitrogen from the air and then give it to the plant. And you can measure a lot of other things like that. So yes, desert full of treasures, of microbes, And then I believe, and all the authors in this paper, that the microbial community of the desert will provide a lot of solution, not only in agriculture, but for different domains like health as well.
Thank you.
Thank you.